In this video, we're going to look at the intermediate value theorem. For any polynomial function p of x with real coefficients, suppose that for a not equal to b, p of a and p of b are of opposite signs. Then the function has a real zero between a and b. The intermediate value theorem cannot be used to determine whether there is or is not a real zero between a and b when p of a and p of b have the same sign. So in other words, what this means is that because polynomial functions are continuous functions, if p of a and p of b are opposite signs, meaning that one function value is positive and another one is negative, then there has to be a value in between a and b that causes the function to equal 0. So in other words, there has to be a real zero between the two values a and b. But if p of a and p of b have the same sign, if they're both positive or both negative, then we can't really tell if there's a zero between the values of a and b or not. So let's look at an example to illustrate this intermediate value theorem. Using the intermediate value theorem, determine if possible whether the function f of x equals x cubed plus 4x squared minus 8x minus 10 has a real zero between a and b. And so in this particular case, a is negative 6 and b is negative 5. So to determine this, we're going to find f of negative 6, that's f of a. We're going to find f of negative 5, that's f of b. And we're going to see if they have the same sign or opposite signs. So if we find f of negative 6, that will be negative 6 cubed plus 4 times negative 6 squared minus 8 times negative 6 minus 10. Now negative 6 cubed is negative 216. Negative 6 squared is 36. And 36 times 4 is 144, so we have plus 144. Minus 8 times negative 6 is going to be plus 48 minus 10. And so negative 216 plus 144 plus 48 minus 10 is negative 34. So f of negative 6 is negative 34, which is a negative value. If we find f of negative 5, that will be negative 5 cubed plus 4 times negative 5 squared minus 8 times negative 5 minus 10. Well, negative 5 cubed is negative 125. Negative 5 squared is 25. And 25 times 4 is 100, so we have plus 100. Minus 8 times minus 5 is going to be plus 40 minus 10. So negative 125 plus 100 is negative 25. Negative 25 plus 40 is positive 15, and positive 15 minus 10 is 5. So f of negative 6 is negative 34, a negative value. F of negative 5 is 5, a positive value. So that means there has to be a 0 between the values of negative 6 and negative 5. So we're supposed to determine, if possible, whether this function has a real 0 between a and b. So the answer in this case is yes, there is a real 0 between negative 6 and negative 5. So yes, there is a 0 between negative 6 and negative 5. Now, is there a 0 between a equals negative 1 and b equals 3? Well, we do the same basic approach. We're going to find f of negative 1 and see what we get. We're going to find f of 3 and see what we get. F of negative 1 is going to be negative 1 cubed plus 4 times negative 1 squared minus 8 times negative 1 minus 10. Negative 1 cubed is negative 1. Negative 1 squared is 1 times 4 is 4. Minus 8 times negative 1 is plus 8 minus 10. So negative 1 plus 4 is 3. 3 plus 8 is 11. 11 minus 10 is 1. F of negative 1 is 1, which is positive. If we find f of 3, that's going to be 3 cubed plus 4 times 3 squared minus 8 times 3 minus 10. 3 cubes 27 plus 3 squared is 9 times 4 is 36. Minus 8 times 3 is minus 24 minus 10. So 27 plus 36 is 63. 63 minus 24 is 39. And 39 minus 10 is 29. So f of 3 is 29, which is also positive. So the fact that f of negative 1 is 1, which is positive, f of 3 is 29, which is positive, we can't tell if there will be a 0 between negative 1 and 3. So it's not possible to determine if there is a 0 between negative 1 and 3 because both function values are positive.